Hello everybody, today we will talk about lab number 3, which is talking about Kirchhoff's voltage laws and at the same time mesh and nodal analysis. So today we will try to connect this circuit. In this circuit we have 1, 2, 3, 4, 5 resistors and 2 voltage sources. We will connect these resistors in that configuration and then we will measure I1, I2, I3, I4, I5, and V1, V2, V3, V4, V5. What is needed is I would like to validate what we have already studied before in Kirchhoff's current law and Kirchhoff's voltage law. We have to prove that summation, the current at this node is equal to 0. So I1 plus I2 plus I3 is equal to 0. And at the same time, summation the current for this node is equal to 0. I3 plus I4 plus I5 is equal to 0. Summation the voltage for this loop is equal to 0. Summation the voltage for this loop is equal to 0. Summation the voltage for this loop is equal to 0. This is the first part. The second part, I will disconnect this guy and I will connect diodes and I will try to put the negative terminal here and the positive terminal for the diode here. So this is our diode that we are going to talk about. This is the negative terminal and this is the positive terminal. How did I know? The shorter one is the negative and the longer leg is the positive. So I will connect this guy instead of this resistor and I'll do the same, measure the voltage and the current, and I will try to check if still KCL and KVL are still working or not. Let us right now start connecting our circuit. So what I need to use two different voltage sources. So I will connect my voltage sources between this point and this point. So this is the positive terminal and this is the negative terminal for the voltage source for 6 volt. And for the other one, I'll try to do the same. I will have two different sources. The second source here, which is this guy, this is the negative terminal and this is the positive terminal. So this volt is 6, this voltage is 6 volt and this voltage is 12 volt. I will connect these two to my power supply and measure. And after that, I would like to connect this negative to this negative. As you are seeing, they are connected from here. So what am I going to do is I'm going to connect this negative to this negative. I told you all of these are the same and all of these are the same. So I connected these two, which means this point and this point are representing that. Then I will try to connect all of these resistors. So first of all, I would like to connect 100 ohm, which is this guy. It is connected where I will connect it here, for example. Anywhere, it doesn't matter. But I would like to connect this guy to the positive. See here, this guy is connected to this positive. So I will take signal from this guy. So I will take this signal, for example, and I will connect to the positive terminal here. This guy is representing this. Then I need to connect here as well this resistor, which is 750. So for 750, this resistor is 750. I will connect it between this and, for example, this point. It doesn't matter where, because all of these are the same. I mean, this one is the same spot. This one is the same spot. So right now, this point is representing this point. And I need to connect this resistor, which is 470. So for 470, this guy, for example, I will connect it like that. But I would like to make these as one node, because here, as you are seeing, these are one node. So I will connect this guy to this guy. So right now, those are representing this. And at the same time, I would like to connect this point to the negative side of the voltage source. So I will connect this to the negative source here. So right now, this guy is representing this part in my circuit. And this guy is representing this part in my circuit. What else? I would like to connect 330. So for 330, imagine that this resistor is 330, it is connected here between this and, for example, this. So these three resistors are sharing, which are those, the same nodes. And this one and this one, which are those, are sharing this node. What is left? This guy. So I will connect here the last one, which is, for example, 330. So I will connect it here to this node, and it will be over there. Then this guy is representing this guy. And these three are sharing this point. And these three are sharing this point. Now, what is left? I would like to connect this guy to the positive terminal, like here. This guy is connected to the positive terminal. So I will take wire from this guy to this guy. So I will connect this wire to this guy. Then the negative terminal is connected to this. So this negative terminal, again, it is connected to this point. So I can do that here by connecting this negative terminal again to which point? To this point. Actually, this guy is connected from here because I took this negative to this negative. So I don't need that because this guy also is representing the negative is connected to the negative because this guy is negative. It is connected to this point, and this point is connected back to the negative. So I could remove this because this guy is representing, as you are seeing, those are representing the same. This is the circuit that we are going to talk about, and I will connect my power supply here to 6 volt and this guy to 12 volts. This is the same, but I did that because I would like to use 2 colors, one which is red, which is representing the positive, and the negative is represented by the plague. So those two are the same negative represented by this wire, and this is my circuit. As you are seeing, this is my circuit. I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is my voltage source. Like what I said at the beginning, I connected my voltage source between these 2 points and the other one between these 2 points. So this is my voltage source. This is 12 and this is 6. I will turn on, but before start measuring anything, I would like to be sure that I have actually 6 volts from this side, and I have from this side 12 volts. So I will adjust my multimeter to measure voltage DC here, and I'm going to measure the voltage between this point and this point. I adjusted it to measure almost 6. I can change by playing with this variable. And by the same way, I will adjust my other source. It is almost 12. It is 1199, almost 12. What is needed? I would like to measure which voltage, this voltage, this voltage, this voltage, this voltage, this voltage. The voltmeter is connected in parallel. So it will not make a big problem for me to measure the voltage, because what am I going to do? I would like to measure this voltage. This is the positive and this is the negative. So I will connect it like that and see the voltage value, which is representing V1 2.423. And then I would like to measure V2. This is the polarity, positive here and negative there. So the voltage is V2, it is equal to 9.54. Then I would like to measure this voltage again, which is V3. It is almost 3.8. Then I would like to measure V4, which is this guy, in parallel. It is almost 5.7, 5.744. Then last voltage, which is this guy, in parallel also, it is V5, which is negative 0.253. Why it is negative? Because of wrong polarity. If you would like to switch the polarity, the sign will be changed, like what you are seeing. Now, I would like to measure the current, so I will adjust my multimeter to measure the current, like what I'm doing right now, and then I will connect this guy to measure the current here. So for measuring the current, I will connect my ammeter in series. What do you like to measure? I would like to measure the current in this guy. So for measuring the current in this guy, I will disconnect this guy. Then I will connect my ammeter between this point and this point. So I would like the current to go from this source to the circuit. So it's going up. So this is the positive terminal, and this is the negative terminal, because the current is moving from this guy to this guy. So as you are seeing, the current in milliampere is 0.024 or 25 milliampere. Then I would like, after that, to measure which current. The current that I have already measured is I1. I would like to measure the current here, which is I2. I2 is the current in this guy. So I will disconnect this resistor, put it anywhere here. And then I will connect the positive to this one. It is opened here, and I will close my circuit to this one. I'm measuring right now the current, which is the current here. The current is almost negative 0.013 milliampere. Then again, I will repeat the same story, but let me return this back. Disconnect this guy and measure the current I3 in this resistor. So I disconnected this, and I would like to measure the current towards this way. So this is the positive, and this will be the negative. The current is inside this resistor. Like what you are seeing, the current is equal to negative 0.012. This is I3. Then I will reconnect this back. And I would like to measure the current in this guy, so disconnect this. And again, I would like the current to be downward. So the current is going from this terminal, which is the positive, toward this terminal, going down. The current is 0.012 milliampere. This is I4. Last current, I will return this back. Last current, which is the current in this guy. So I will disconnect this. I would like the current to go in this direction. So this is the positive and this is the negative. So I will connect the positive here and the negative here. The current is equal to negative 0.001 milliampere. If you would like to see positive, this is the right value for the current based on the direction that I have. If I switch the direction, I will see positive instead of negative. But I didn't ask you about that. I asked you about this direction. This is the right direction I asked you, negative 0.001. This is the first part of the lab. The second part is to do what? He asked you in the second part to disconnect this guy, which is this resistor. Let me switch off. Disconnect this guy and connect the diodes instead, and check if still KCL and KVL, if they are still working or not. So this is the diode. I connected it. I will switch on, turn on, see the diode is on. And what I would like to measure, I would like to measure the voltage again, V1, V2, V3, and so on. So I would like to measure V1. So V1 across this resistor. So this will be V1. Let me put this here. So this will be V1. 2.964. Then I would like to measure V2. So this is the positive terminal, V2. It is 9 volts. I'd like to measure V3. This will be V3, 2.05. I'd like to measure V4. This is V4, 6.94. V5, this is V5, 0.946. Then I would like to measure the current, so I will adjust this guy back to measure the current. So I would like again to measure I1, which is the current going from this guy to this guy. So I disconnected this. So, or I can disconnect this as you like, doesn't matter. And then I will connect between this point and this point. The current is 0.03 milliampere, which is I1. I will return this back, and I will return this back. I would like to measure I2, which is the current in this guy, so disconnect this. And I will connect the positive to this because the current is going up from positive to negative. This is I2, which is negative 0.012. Then I would like to measure what else? The current I4, which is the current here. So disconnect this, and the current is downward, so it's going from this terminal positive to this terminal. So the current is 0.015 milliampere. Then I would like to measure the current here going this direction. So I will disconnect this guy, and I will connect the positive here. I will connect the positive across this guy and the negative across this guy. So the current is 0.003 milliampere. Last current, which is the current in the diode. So I will disconnect this one, and I would like to measure the current in that direction. So this is the positive, and I will close this point. The current is negative 0.018. These are all values that I have already measured for the voltage and the current. What is needed from you is to compare all of these with the theoretical values by using KCL and KVL and mesh. And this is the circuit that we are talking today. Thank you so much for listening and watching that video. I'll see you for lab number 4, and bye for now.